So if you've been on the internet at all recently, you have definitely seen them. These talking skeletons sharing, deep thoughts in a super cinematic voice. It's a huge trend, right? But what if I told you the real story here isn't just about a weird viral video, but about a genuinely surprising scientific discovery that kind of challenges everything we think we know about our own attention spans? All right, let's get into it. It all starts with a number, 19 million. That's how many views just one of these AI skeleton videos got. I mean, entire channels are popping up overnight, gaining hundreds of thousands of subscribers just by posting these little clips. The scale here is just staggering. Which, of course, leads to the big question of this whole explainer. Why this? Why are these kind of strange, sometimes creepy AI skeletons absolutely everywhere all of a sudden? Well, to figure that out, we first have to break down what's really going on inside these videos. Yeah, see, this isn't just some random thing that caught on. This is a very specific, almost scientifically engineered formula. The people behind this trend have figured out this incredibly powerful recipe for grabbing our attention, and it's turned into this full-blown, mysterious obsession online. So what are they exactly? Well, it's almost always a skeleton character, and they're either telling some really emotional story, or asking a deep philosophical question, or maybe explaining some dark, fascinating fact. They're all narrated by that same deep, cinematic AI voice, and every single piece of it, the image, the voice, the words, is designed to do one thing: spark your curiosity and make you hit replay. And believe me, this is no accident. And all of this has basically become a playbook for creators, because once you see the formula, you realize just how easy it is for pretty much anyone to make this stuff, which is exactly why it's spreading like wildfire. Most creators are following this super simple 4-step viral formula. You start with the core concept, you generate an AI image, you animate that image to turn it into a video, and then you add all the cinematic editing tricks that give it that signature, mysterious vibe. But you want to know the real secret here? It's not actually about the AI. According to the creators who are sharing their methods, the entire thing is built on having a strong concept. The key, they say, is just to be short and thought-provoking. The AI? That's just the tool you use to bring the idea to life. And here's the actual toolkit they're using. They'll start by asking something like ChatGPT for curiosity-driven video ideas. Then they hop over to an AI image generator like Google Nano Banana to get those super realistic skeletons. From there, an AI like Google Flow makes the image move and talk. And then for the final step, an editor like CapCut is used to add the dramatic music, the big bold captions, and those intense zoom effects. It's a complete AI-powered assembly line for making viral content. But that brings us to the real heart of what we're talking about today. I mean, it's one thing to understand how these videos get made. It's something else entirely to ask, what is the actual real-world impact of all this nonstop, super fast-paced content on our brains? Come on, let's be honest, we've all wondered this at some point. Is this endless fire hose of short-form videos actually damaging our ability to focus? Is it, for lack of a better phrase, breaking our brains? Well, a team of scientists decided they wanted to actually test that question. And that takes us from the internet right inside the scientists' lab. Researchers at San Jose State University designed this really fascinating experiment to try and find a real, evidence-based answer to the whole TikTok brain debate. The setup was actually pretty simple and kind of brilliant. They brought in 110 TikTok users and split them into two groups. The first group was told, just watch your personal TikTok feed for 10 minutes. Easy enough. The other group, the control group, was asked to work on a 300-piece jigsaw puzzle for those same 10 minutes. The big question was, would there be any measurable difference in their attention right after? Now, to measure that difference, they use this really powerful tool called the Attention Network Task, or ANT for short. The cool thing about the ANT is that it doesn't rely on asking people how they feel about their attention. No, it's an objective computer-based test that precisely measures 3 different core attention networks in your brain. Basically, it flashes things on a screen and measures how fast and how accurately you respond, giving a really clear picture of your brain's attention systems at work. So what are these 3 networks? Well, first you have alerting. Think of this as your brain's ready, set, go system. It gets you prepared for new information. Then there's orienting, which is your ability to shift your focus, like when you hear your name called in a loud, crowded room. And finally, and this is the big one, you have executive control. This is like your brain's CEO. It's the part that helps you ignore distractions and really stay on task. So the stage was set. The TikTok group had watched their videos, the puzzle group had done their puzzle, and both groups sat down to take the attention test. And, everyone was expecting one particular outcome, but that is not what the data showed. Not at all. The common assumption, right, and even the researchers' own hypothesis, was that a 10-minute TikTok binge would hurt your attention scores. I mean, it just feels true, doesn't it? All those fast-paced videos must make it harder to focus afterward. But here is the jaw-dropping result. When they measured executive control, that key ability to filter out distractions, they found no significant difference. 0. The performance of the people who watched TikTok and the people who did the puzzle was, for all intents and purposes, identical. And it wasn't just a fluke with executive control. When they looked at the other two networks, alerting and orienting, it was the exact same story. Statistically speaking, their scores were identical. Those 10 minutes of TikTok had no measurable negative effect on any of the core attention networks that they tested. But they didn't stop there. They also wondered about long-term habits. So they checked to see if there was a link between a person's total TikTok screen time and how they did on the test. And again, they found nothing. No link. It seemed that neither a brief 10-minute exposure nor a person's long-term usage habits had any impact on attention, at least as measured by this test. So that brings us to the final, and let's be honest, the most complicated part of this whole story. What are we supposed to make of these results? Does this mean all that talk about TikTok brain is totally overblown? Just a myth? Well, not so fast. Because, like all good science, the answer is not a simple yes or no. A single study is never the final word on anything, and the researchers themselves are quick to point out that the story is way more complicated than that. Now, while the study didn't find that direct link to attention scores, it did find some other really interesting patterns. For example, younger participants and people who had been on the app longer tended to have much higher screen time. And kind of surprisingly, most people were pretty accurate when they guessed how much they used the app, which suggests we're all pretty aware of our own habits. And this right here is maybe the most crucial piece of context. The study's lead author, Samantha Shannon Sutrisno, points out a key limitation herself. She says the attention network task, it just might not be sensitive enough to pick up on more subtle, nuanced changes to our attention. In other words, something might be changing, but this specific tool might not be the right one to measure it. Which leaves us wrestling with this huge final question. If this endless stream of viral content, from talking skeletons to whatever the next trend is, if it isn't measurably changing our core attention networks, then what is it changing about us? What does it change about our expectations, our patience, or that sense of curiosity that makes us keep scrolling in the first place? That is a question that science is still very much working to answer.